After drawing more than 150 times the Oracle structure, I've decided to produce an animated video. Let's start first with the database structure. On the left side, you have the client tier. On the right side, you have the server tier. The server side is divided in three main structures: the memory, the logical structure, and the physical structure. So let's use SQL Plus application to provide you every step of a transaction. We will be using Scott sample schema. It is important to know that the host string is an alias and not a database name. The string will be compared to this alias inside of a file called tnsname.ora. This file is similar to a DNS and will obtain all the necessary detail to reach the database server. Locally, a user process will be allocated and will validate the connection through a listener. The listener will be in charge to allocate a server process. The user process is now linked to the server process. Let's now execute our first transaction. For this example, we will execute an update. First, the statement will be validated. We call this step the parsing. The server process sends back the confirmation of the parsing. The statement will then be written into the share pool and the redo log buffer. An execution plan will also be created into the share pool. The database block that is used for the transaction will be read and copy into the database buffer cache. Only the field implicated in the transaction will be held into an undo segment till the transaction is completed. We call those copies the before image. A copy of this block will be duplicated with the updated field. This copy is called the after image. A confirmation will be sent to the user process. The commit statement will complete the transaction and will be written into the redo log buffer. The commit statement triggers the log writer process and will send all statement for the current transaction into the redo log file. The before image in the undo segment could be then deleted when the threshold of the undo retention parameter is reached. A last confirmation will be sent to the user process. When the current log is full, it generates a switch log, triggering at the same time the archiver process and the log sequence number. The archiver will generate and archive the file with the content of the current log. A switch log will then trigger a checkpoint process that will increment the checkpoint number by applying this last number into each data file header. The checkpoint process will finally trigger the database writer process and write the last image from the database buffer cache into the table.